Well, there's basically two ways to set up a rotary table on a mill, on the horizontal, obviously. You can do it the super precision way, or you can do it the down and dirty quick way. And it depends on how close tolerance your equipment is and how precision your quill is and that kind of stuff. But if you've got a good machine that's fairly tight and everything holds pretty close tolerances, within 1 or 2 thousandths all the time, then you're probably going to be able to get away with doing it the quick and dirty way, depending on how precise of a cut you need on your rotation. If you're looking for a 1 or 2 thousandths tolerance cut, then you can get away with doing it this way. The long and complicated and processed way is to use a center finder or an edge finder and to center off your quill, make your rotations, make sure everything's within your tolerance levels. And that's with either a center finder or an edge finder. But if you have a setup like mine, where you've got a plate on top of your rotary table, and your plate is already well centered, and that takes a while to do to get it set up right the first time. But if you don't ever take the plate off and it's centered to begin with, and everything's really true, then there's a quick and simple way to do this that'll get you within a couple thousandths. What you do is you take a piece of precision ground round stock that matches the center hole on your plate, and you use it to center your rotary table. Once you're centered on the true center of your rotary table to where there's no friction on your ground piece that matches your hole, then you know your rotary table's centered. Then you take whatever piece you're going to put on there, if it's got a hole clear through it like I'm setting up for. Take your piece that's put on there, you take a piece of stock that is matches your hole, which, like I said, this hole's slightly undersized, so this piece of round stock's slightly undersized. It's actually a few thousandths smaller than this. So you take your piece of round stock that matches your pinhole, and then run it down through your piece, get everything in place to where your quill is held in center, clamp everything up, tighten it all down. If your quill comes back up out of the hole without friction or drag, or isn't binding anywhere, then everything should be true to this hole. And then you want to check it in 3 different axes if you're like me. Like this cut that I'm going to make is 180 degrees, or nearly. It won't be quite 180 degrees, but it's basically going to be half of the full circle. And so if you check it in this position, this position, and this position, and the quill, the pin is still going in smooth all the way through and it's not binding or catching anywhere, then you know that you're centered within 1 or 2 thousandths. And so it's kind of a quick and dirty way to do it, and it won't get you super precision tolerances. But if you need to, if you just want a few thousandths tolerance to where you're close enough to where you can hand fit, then this is a quick way to set up a rotary table. And my rotary table obviously is considerably massive for the size of mill that I have, but I got it a few years ago used. It was a really good deal, and it's a 1950s era Pratt & Whitney 12-inch rotary table. And so good old chunks of American iron like this, when you come across them for a good price and they're still in good shape, never hurts to buy them up. Especially if they're usable on the equipment you've got. So anyways, that's the setup. It's clamped in on an angle plate, and then the piece is actually clamped to this. Everything is tightened down really good and tight, and I've got good clearance in all 3 positions, so that I'll be able to make my rotation and everything clears really nice. So anyways, you get the idea. That's the setup on that. It's not super precision, so if you're looking for really tight tolerances, this isn't the way to do it. But if you're looking to save some setup time and take a full probably 2 or 3 hour setup and turn it into an hour or so, this is a quick way to do it if you got the similar setup to what I have. So anyways, I'll go on with this. What I'll do next is I'll make my offset to how much radius I want out here. Then I'm going to lock all my jibs in place, and then I'll just start cutting back and forth and work my way all the way down through the length of the block until it removes all that. So that's how it's done. The other thing I should mention is you want to make sure you check all your clearances once you get everything set up. One of the things I had to do was, this is my quill stop, and I had to take my quill stop out because this sticks out just a little bit below the bottom of the quill, and I needed that extra little bit of clearance to get my cut. So, and of course, if you have long end mills or something, you can get away with doing it a little differently. But for standard size end mills in order to get the maximum amount of cut out of them and have it clearance and everything. I had to take my quill stop out. So you want to check your clearances and stuff before you get all set up and start cutting, and then get down to depth and find out, oh, can't quite finish it. So there you go, little tidbit there just in case you ever run into that problem. Okay, so the next cut I want to make is I want to clean this up to where I've got a nice 90-degree shoulder at the top of my radius. And the way I did that was, obviously my radius is true to my hinge pin hole, so I know the face matches the pin. So I just put my dial indicator in there, used my rotary table, clamped it, to the parallel to the block, and then trued the rotary table until I knew I was running a straight cut here. And then I'll come in with my cutter and trim that off and make it nice and square. Well, there we have it. There's the radius and the nice shoulder. That's where the forearm hanger piece will butt up against nice and tight, and everything will radius nice. One of the things you'll notice here is that this radius is offset slightly of the center of the hole. The radius follows the curve, but it's slightly smaller diameter. And the reason for that is if it were a perfect radius that was true to the center line of everything, then you wouldn't be able to swing the forearm down because it would only swing until it hit the bottom here. So giving it a little bit of slight offset gives you clearance for when it swings down and allows it to open down into this section. There's a couple different ways that these are done on a lot of double rifles. Offsetting it works really good and gives you a nice, pretty clean line. Everything follows a nice straight line. The other way it's done is the underside of these are sometimes machined out to allow a little pocket recess, and it gives you a little dimple that you can visually see when the gun's all put together, but it's a clean look also. So there's a couple different ways it can be done. I just prefer to offset it a little bit. It gives you the clearance you need, and it's a lot easier to work with. So anyways, as you can see, it's got a nice big chunk of steel that bridges across here, so it's well supported on over half of the pin is well supported, even in the open section in the center. And of course there's massive amounts of material in here, so tons of strength in that. And when things start going together, obviously all of this will line up and work like it's supposed to. So that's where I'm at for the moment. I'm going to set this up. I'm going to do a little bit of layout work, and then I'll set this up to start cutting the radiuses that will be the outside overhangs of the breech face, and it'll also be, of course, where the firing pins center through and all that. But so this radius here that comes back like this will have to be cut on both sides, and of course rotary table is a nice easy way to at least start those cuts. It'll give me the nice clean radius on both sides. So I'm going to do a little layout, and I'll get it back up in the mill here in a little bit. So I'm back on the rotary table here, and I'm ready to start making the cuts to radius off the back side of the breech face. And this really isn't much different than the way I radius the front. Just took a little longer to set up. What you need is a edge finder, and what you have to do is find the center your rotary table to start with, then find the edge, the breech edge, and then you have to find an edge and move it over to center. That way you can move out when you're on single axis. You can move out your radius distance, and then you'll be able to cut an even radius all the way around. And I just made a real light shallow pass just to make sure everything was cutting where I wanted it to. And now I'm ready to go ahead and machine it down to depth here, and then I'll flip it over, re-index everything, and do it again. So that's where I'm at. It took about an hour to do this particular setup here, and I imagine it'll probably take about the same amount of time on the other side. It's just a matter of using edge finders and indicators to get everything exactly where you need it before you start making your cuts. Make sure you lock everything in real solid, and the rest is pretty easy. pretty nice radius. So there's one radius done, fully cut. You'll notice that it doesn't quite go clear to the top or clear to the bottom. The radius comes out just shy of, it's just slightly oversized is what I mean to say. You can see that it left an edge back here instead of bringing the radius clear out to there, and I did that on purpose. One, because this radius actually stops short of where the shoulder is, because there's a radius down here, and so I wanted to be able to polish this in by hand, file it and whatnot by hand to get it to come out to a nice smooth edge. And then on this side, of course, it stops just a little short of coming all the way to the edge, because when I fit the two together, I'll come in and make one clean surface cut that brings it all, ties it all together and smooths it all up. So it'll blend all the radiuses in together with the other parts as they come together. So that's why I came just a little bit bigger than I needed to be, but it's not much. It's only a few thousandths on each side, so should be pretty easy to clean up later. Now I'll flip it over, re-index everything, flip it over, and make the same cut on the other side. Okay, so I have both radiuses cut in this. You can see they turned out fairly decent. Pretty nice matching set. Not too bad. This one I got a little bump in it here, but it's no big deal because that whole corner is going to go away eventually. The next two cuts are going to be the radius that goes from here to here. The quarter radius of this same radius here, basically. And it's a little hard to describe, and not everybody understands the visual concept, so I whipped up a quick little block here. What that cut's going to do is it's going to give me this shape here. That's going to give me this cut, and it'll leave this sharp edge down here, but that's not a big deal, because later in the project, after the monoblock's fitted and the barrels are contoured and fitted to the monoblock, then I'll match that contour all the way back, and I'll take that whole corner off to match the radius and round it all over so that it makes a nice dome shape out of the whole thing. So that's where I'm going next with this, is it'll be this cut to make this radius here, and then I'll do the opposite side, and then later in the project when things start coming together and I start fitting up, I'll make this final radius to give it that dome shape all the way through. And of course that dome shape is going to carry on through into the tang top and all that, so that it all contours and fits together, has that nice shape that's in the drawings. So, but that's where we're headed with this, and that's last week's work and today's work up to date, and I'll continue on tomorrow with machining these radiuses here and start whittling away some more of this. But it's generally starting to take on the look of an action. Eventually it's going to get there. It's just a whole lot of metal to remove. Incidentally, for you would-be machinists out there, this is a really great way to figure out your next cuts and make sure everything's going to work the way you want without screwing up the piece you're working on, especially when you're doing one-off pieces like this. Take a good piece of hardwood that's going to take a cut really well, and just make your next cut. If it doesn't work the way you want, set it up differently and try it again from a different direction. But at least doing it this way, you're only screwing up a scrap of wood. You're not screwing up the piece you're working on. So that's just a nice little tidbit you can all use for cutting this stuff. Obviously, without a mill and a rotary table, this stuff would all have to be hacked out with a hacksaw and hand filed. So having a mill and a rotary table that'll handle this size of work, or the piece of work you're doing, really helps a lot. But this is one way to keep from making mistakes on the actual finished product. You can check your next cuts just by throwing a block of wood in and making some quick passes and seeing if it turns out the way you want.